All right, so to recap what we have done, factoring, we factored trinomials of these two forms, special formula included. Okay, so the special formula would also include such as a squared minus b squared, right? And that's going to be a plus b times a minus b. I think by this time you guys are rather familiar. And there are also that there's these perfect square plus 2ab plus b squared, and that equals to a plus b squared. And of course, and the other special formula will be a plus a minus. So I'm going to combine these two into plus minus. So these are the special formula along with the technique we use for quadratic, for these quadratic forms. Okay, we call them trinomials. And of course, factoring by grouping. And factoring by grouping, which we talked about last week. And in terms of all these methods, you really can use very flexibly, and even for trinomials, as we have indicated last time, you could do it by grouping. Okay. Next, we did alpha 42 last week as well. Okay, which is by, which is they're all perfect squares. You just have to compose this perfect square any which way you want to do. Okay, you can go by the special formula itself, or you can go by just set up the factoring. Okay, so with that said and done, so let's look at 43. That's today we're going to look at 43. 43, hold on, what did I do there? Oh, okay, so let's look at 43. Okay, 43 is about factoring, needing a little bit more techniques. Okay, I accidentally moved this, moved the notes too fast. So you guys should be looking at alpha 43. Alpha 43. Are you guys there? Here I am. I was there, and then I was, for some reason, I just, something jumped. Anyway, so today we're going to look at alpha 43, sorry, alpha 43, which is, the title is Factor Completely. Okay. So besides all the technique we have learned, right? Take the first example. What do we mean by factoring completely? Suppose we have x raised to the power 3 plus 5x squared plus 6x. We have three terms here, but we cannot use it doesn't fit these forms, okay? These two forms of trinomial, it has a special characteristic. You see, this is 2, and this is a half of 2. Okay, so this is 1, and this is double the 1. Okay, and these kind of factoring technique can be extended to if this is 2, and that is 4. Okay, we're going to talk about those examples later. So for now, just a 2 and 1. And the relationship between these two powers is one is, the highest power doubles the next one, doubles the power of the next one. So in this case, one of the most straightforward thinking is that you can see every term in these three terms, they have an x. So we can factor out the x first. So as a result, we get x squared plus 5x plus 6, right? And we know how to factor this the three, you know, three terms in the parentheses. You can use any way we want. And in fact, this is pretty familiar to us, right? So it's just x plus 3 times x plus 2. Okay, do you guys want to try one? Please try number 2. Please, you guys, try number 2, please. 2. If anyone would like to show your work, and I would love it. I would love it. Okay, in my previous class, I got people to show their work. Even for the same question, I get multiple different versions. So I get to, you know, point out the different kind of ways you can show your work. And also the common mistakes are, you know, they were showing up in the work students show to me and to the class, and which benefits everybody. Okay, so I was basically grading the work in front of everyone, and everybody learned something. Hello, picture. Oh, sorry about that. Okay, so x raised to the power 3. So can you guys factor that? So that would be similar, right? I'm sure you can do it. So x squared plus 7x plus 10. And that equals to x times, you can use a, you know, factoring trinomial technique to work on that. And in fact, this is some, you know, one of those factors we have done. So we just go straight to it. Okay, x times x plus 5 times x plus 2. Done. That's called a complete factored, completely factored. Okay, so let's keep going. We're skipping number 3. I think I'm going to leave number 3 for you. Of course, you're going to do all of these all over again. So let's head into number 4. Number 5. Would you like to try number 4 and number 5? Please try. Okay, so number 4 is x raised to the power 3 minus 9x. Number 5 is 10 times x squared, 10 times x squared plus 50x plus 60. So please try them. Anybody, or if you've done your work on the paper, and just take a picture and send it to Pronto, or to upload to the file. Okay. Hi, Francisco. I see your message. Okay. Anybody else? Anybody would like to show your work? At this point, you can use any way you want. You can use any way you want. Okay, but you can see the way we factor number 1, number 2. The first step we did, we factored out something you probably have heard use that word called GCF, the greatest common factor. The greatest common factor. GCF means greatest common factor. Okay, so G, C, the greatest, C, common factor, and F right there. Okay, the greatest common factor. So the greatest common factor on number 1, number 2, they happen to be X. So what would be the greatest common factor if there is any? Okay, sometimes there isn't one, or the greatest common factor is just 1, right? Of course, you always have 1 as the greatest common factor, but factoring out 1 doesn't make much of a difference. So we just, you know, we don't factor out the 1, we just keep going, right? If we have a greatest common factor, then we just go factor it out. In this case, anybody want to show your work? Anybody? No, you're being shy? Are you being shy? Yes, are you being shy? Are you being shy? You're not losing any points or anything. You just show your work, and then I can, you know, tell you what step is right, what step is wrong, and then everybody will benefit. No? Anybody? All right, that's okay if you don't, if you're not ready. So let's look at x. We factored out the x, so we get x squared minus 9, right? And using special formula, because this one, in this case, we got x times x squared minus 3 squared. Now, in the end, we get x times, this is a squared a squared minus b squared, so we ended up with x plus 3 times x minus 3. Okay. The next one, the greatest common factor is a 10. So we can factor out the 10, so we get x squared plus 5x plus 6. And that equals to, and then we're just going to factor x, well, this one we just already did, so that's going to be x plus 3 times x plus 2. Done. Right? Is it easy? Okay. Would you like to try number 6 and number 8? I'm going to give you a couple minutes this time. How about 5 minutes? 5 minutes may be too long. Okay, so number 6, we get 100x squared minus 400. Okay, number 8 is 5 times x raised to the power 3 minus 45x. Okay, so your turn. Your turn. Please try. How about 4 minutes? 4 minutes. Okay, 2 minutes for each. It might be too easy for you, but do it anyway. Do it anyway, because then we're going to move on to the next section. We're going to move on to the next section. You got it? Did you get it? On number 6, there are actually 2 different ways to do it. Okay, one way is you just factored out the 100, and then you have x squared minus 4, and 4 is 2 squared. And there you go. You got your factors. We got our factors, which is going to be x plus 2 times x minus 2. You probably got that as well. And you can also, okay, you can also do this way if you want. Okay, I do like the first way though, right? It's just a little simpler. But if you do it this way, you still get the same answer. So here you're gonna have 10 times x squared, right? Minus 20 squared. then you will end up with, the capital A squared minus capital B squared. So A is 10x, B is 20. So you will have two factors, right? So 10x plus 20 multiply 10x minus 20. But this will not be considered completely factored though, okay? You would also factor out the 10 from each factor, right? In the first parentheses, you can factor out the 10. So you have x plus 2. In the second parentheses, you can factor out another 10. So you have, like this. So in the end, you will still get 100 multiply x plus 2 times x minus 2. So either way is okay. Either way is okay. Okay. Number 8. Okay. Number 8, we would like to factor out the greatest common factor, which is 5 times x. 5 times x. So after that is being factored out, we get x squared minus 9. And once again, you get these factors by special formula. Okay, so x plus 3 times x minus 3. I think we can have a closure on this one, right? Next session today, we are going to, we're going to work on alpha 44 today. Alpha 44. Okay, alpha 44 is solving for x. It's an if statement. Okay, it's that if statement. All of these we did about factoring, they're just a statement. They are just statement, right? You don't have another side given equals to something because they're not, they're just given as a function. So these are just a function. You can see them as a function. This is a rule. These are just the rules, okay? And on 44, however, is the context will be now if, right, a specific function, if a specific function, and there's, for that function, there's input, and the output is given as certain number, okay, but the output is given. The output is given, okay? For example, number 1, okay? I still want to remind you the different perspective, even though finding the solutions is pretty straightforward. For example, the first one, x minus 3 times x plus 5, right, is equal to 0. So what is the full meaning? What is the full meaning of it? Okay, the full meaning of this is that saying if this function has an output equals to 0, okay, or you can also view this as in this form, right? If, right? If the input is unknown, the output is produced this way, and the output we want it to be 0. So we're going to determine, right? We're going to determine, so find x. Find x. Find x. Okay, so this is how, how we understand the sentence. How we understand the sentence is an if statement. So how do we solve it? How do we solve it, right? If this is true, is there a principle that is relevant to this question? Would you like to look at principle number 5? Principle number 5. If A times B is 0, if A times B is 0, then A is 0 or B is 0. Remember that principle? Yes? So we can use this principle. We're going to view x minus 3 as A, x plus 5 as B. Okay, so this is a capital A, sorry. Okay, so this is a capital A, or this is a capital B. So the product of two numbers is 0, then one of them must be 0, right? And then following principle number 5, x minus 3 is 0, or x plus 5 is 0. And then we just solve these, each individual equation. We get x equals to 3, or, okay, let me change to math mode. And the other one would be x equals to -5. So solution, okay, the solution, I want to show you a new way to, to show the solution. You can show your solution like this, okay, -5 or 3. Okay, we use a curly brackets. We basically enumerate, okay, so it's enumerate the solution. We just have two solutions, so we just put them in the curly brackets and telling the reader, hey, this is the collection of the solutions. This is a collection of the solutions. All right, so let's try another one. Okay, so this time we're going to try, how about we try number 2? Do you want to try number 2? Five x times x minus 7, x plus 3 equals to 0. How do we view this? Okay, how do we view this? We view this as a product. Of course, it's an if statement, right? We view this as 5, right? 5 is a number. And the x, we view it as a capital letter A, x minus 3 as a capital B, and x plus 3 as capital C. So 5 times A, B, C. Okay, so this statement, okay, so let me put it this way. 5 is a number, x is a number. We don't know. X minus 7 is a number, capital B, capital C. So A times B times B times C, if this product is 0, well, certainly 5 will never be 0, right? 5 will never be 0 because it's a 5, right? But A may be 0. So this is the extension of principle number 5. What is the extension of principle number 5? Principle number 5 says, right? Principle number 5 says, okay, principle number 5 says, if the product of two numbers is 0, then what if you have ABC, right? What if you have ABC? Let me write it down. If the product of A times B times C is 0, what can you say? What can we say about ABC? Right, so principle number 5 is such, but what if we have A times B times C? And of course, that would be A equals 0, right? Or B equals to 0, or C equals to 0. And you can see this principle can be extended to 3 numbers, A times B times C. It can be extended to 4 numbers, A times B times C times D, and so on and so forth, right? So we're going to use principle one more time. Some people, however, would like to view 5x as a capital A. Okay, that is okay. That is okay. Okay, so or you just simply ignore the 5. Why do we ignore the 5? Because 5 will never be 0. It has no role to, it doesn't play any role to make the product equal to 0. Okay, and the other thing you can do though, algebraically, if you wish, okay, you can take this entire equation and divide both sides by 5. So this way you get rid of the, the 5, because it's totally useless in this context. And we just simplify it. Can we divide both sides by 5? Of course we can, right? That's principle number 4, right? You can divide or multiply by a non-zero number, and 5 is not a 0, okay? Or it can be viewed as multiplied by 1/5, okay? Multiply by 1/5, okay? So let me write it down in the form of 1/5, right? If you multiply by 1/5, right? So, and that way we will end up with x times x minus 7. So this will be the form of the product of 3 numbers. But anyway, regarding this product, right, with the understanding of the extension of principle number 5, and then, you know, you can just go set up the equation. So x equals 0, right? Or x minus 7 equals to 0, or x plus 3 equals 0. Okay, so if x equals 0, the whole product will be 0. If x minus 7 is 0, the whole product will be 0. Or if x plus 3 is 0, the whole product will be 0. So as a result, you know, the first part is already done. This part is done. Okay, so this part is done. And we just have, you know, how the last 2 equations, right? Or x equals to -3. Okay, so solution. Okay, solution. You can box these three as a solution. You're done. You're set. Just alternatively, okay, you can also express your solution as -3, 0, 7. You see, I put them in this order from smaller to larger. You don't have to do that, but it just make it nice, look nice. Make it look nicer. Okay, make it look nicer. So now your turn. Okay, your turn. I'm gonna ask you guys to do number 3, please. Okay, number 3 is x times x minus 4 times x plus 4 equals to 0. So your turn, please. Your turn, please. Take your time. I'm going to give you a couple minutes. How'd it go? How did it go? Got it? It should be easy, right? It's easy. So for this one, we will use the principle, right? You can just say, okay, x equals 0, right? Or x minus 4 equals 0. Or you really don't need much of explanation, really. Okay, just follow the steps. Okay, and the next row, you just finish it. 3 lines. Okay, so x equals to 4 or x equals to -4. Done. Okay, sometimes we have solutions that are fractions. Okay, so for example, number 5. Okay, number 5. For number 5, we have 2x times x plus 3 times x minus 7 equals to 0, right? So we can apply the principles. You can divide both sides by 2, but 2 really doesn't play a role here. So if some of you like to do this, 2x equals 0, that's okay, right? You just treat 2x as one of the numbers, and x plus 3 equals to 0. Or x minus 7 equals to 0, right? And 2x equals 0, that's divide both sides by 2, then you get x equals 0. Or x equals to -3, or x equals to +7. You're done. We're finished. We're finished. Got it? So this is, you can see all of these questions at alpha 44, they have something in common, right? The right-hand side, there's already been said to be 0 if the output is 0, right? If the output is 0. So that kind of statement. What if, right? We have to do factoring. Well, just look at alpha 45. Look at alpha 45. Oops, I'm at the wrong place. Alpha 45. Okay, so what if we look at alpha 45? One thing is certain, it's if statement. If statement again, right? Solve for x, factoring completely. So I put them in the table, right? So in order to solve for x, we have to factor completely first. And these are the questions, are very typical questions that we had seen before. So I'm going to just leave these, I'm going to just do like two or three examples, and then we're going to move forward. Okay, we're going to move forward. I trust you guys can do this, right? So for example, let's see which one. Take number 6, for example. Okay, take number 6, for example. On number 6, right? On number 6, we have x squared minus 3x minus 10 equals to 0. On the same row, we have x squared. Okay, so these two are different. These two are different. This is an if statement. This is an if statement. This is just a statement. Okay, so let me clarify. This is an if statement. Oops. If statement. And this one is just a statement. Okay, so they're very different. And this is the so-called, you guys might have learned that in the previous experience, called equation, right? And these are called expression. Okay, if you want to make a connection to something you might have learned before, this is what your teacher emphasized. What is an equation? I reckon identify equation. Equation is just if statement. Expression is just one statement. Okay, equation and expression also is a function. Okay, expression is also a function. Basically, it spells out a rule, and this rule says, right, X is the input, and the rule is this guy. Okay, so that's the rule. And applying this rule, you're going to produce output. So it's a description of a rule. Okay, and this rule, of course, produces output. Okay, and in the if statement, basically says, okay, if the output is 0. Okay, so now on the if statement, it says, okay, I want if the output is 0. Right? Do you guys understand what it means? So this is the basics of mathematical grammar. This is the basics of mathematical grammar. So let's see what we can do to solve this equation. Solution. Okay, what you need to do. Okay, in order to finish this question for the statement, right, you just factor it. Okay, and I think this is going to be x minus 5 times x plus 2, right? Factor. Any questions about the factoring? Okay, and then we solve it. Solve for x. Okay, and the equation is like that, equals to 0. Remember, this is an if statement, right? So if this is true, then the product is 0. And then we just use principle number 5. Okay, principle number 5. So x minus 5 is 0. X plus 2 equals 0. Right? So in the end, we get x equals to 5 or x equals to negative 2. The purpose that I set up these questions this way is to show you the difference between statement and if statement. Do you guys, are you guys looking at alpha 45? Okay, so let me bring this share with you. You guys see that, right? This column on the left, it shows these are if statements. And the next column on the right, they are just statements. They're just statement. Okay, they're just statement. All right, so let's come back. And some of these questions require some factorings. For example, let's work on number 7. Let's work on number 7. Okay, let's see if you still remember some of those factoring techniques we need. Right? Number 7, if you put it in a table form, okay, so I'm going to make it 2 columns. 2 rows is fine. Okay, so you have on number 7, we have 3x squared plus 11x plus 10 equals to 0. Right? So that's the equation you need to solve, right? So this is solved for x. Solve for x. Right? So that's the category. And the next one, factor completely. Factor completely. You can see the factoring is serving the purpose of solving for x, right? It's solving for x. And this is the statement, right? These are the if statement. Okay. Oops. If statement. If statement. ENT. Okay. And here it's just a statement. Statement. Okay. Or description of a rule, which is a function. Description of a rule, which is a function. Okay. So factor this. So when you work these exercise, you just try to factor, right? So you may need some space on your scratch paper to do the factoring, right? To do the factoring. Do we still know how to do that? Do it? I want you guys to practice this. Okay, are you ready? Okay, I'm going to grab my stuff that I set up last time. Okay, I just want to grab this one. Okay, I'm grabbing this one. So I'm going to bring that with me. Okay, so I just try to figure out what should be the factor, right? 3 is equals to 1 times 3, right? And 10 is equals to 2 times 5, right? 3 times 2, 2 times 5, 5 times, say 5 times 2, right? And then I'm going to do the cross multiplication. Cross multiplication, 3 times 5, and I got a 15 here. I'm sure some of you probably already found the factors, right? So I'm doing trial and error. 15 plus 2 is 17. 17 does not match positive 11. Therefore, this is not going to work, right? It's not going to work. Well, let's try something else. How about change 2 to 5, 2 times 5. 2 times 3 is 6. 1 times 5 is 5. I think we made it. 11. So 11 matches the positive 11 right here. So when we're composing the factors, which is going to be 1 times x plus 2, and this here will be 3 times x plus 5. We got our factors. We got our factors, right? So we can put those factors in place, and you get x plus 2 times 3x plus 5. And of course, we're gonna check it, right? To be on the safe side, we should always check our work if you have time, okay? And so this is the factor you put there, okay? So don't forget to check your work. Okay, so we're gonna check, right? Check. You can just FOIL this and so on and so forth. So I'm gonna save this for you, okay? So I'm gonna just skip that for now. And so we're done the factoring part, and then we're gonna solve the equation. Okay, so now we're solving the equation. Solve for x from here, right? So if this is true, then the product, which is the left-hand side, is equal to 0. And then we're going to use principle number 5, x plus 2 equals to 0, or 3x plus 5 equals to 0. So next, we're getting x equals to -2, or x equals to -5/3. That's it. Our solutions are found, right? Our solutions are found. Okay, so this would take two major steps. And if the factor is very easy, if the factor comes very easy to you, then you do solve the equation faster, right? So I'm gonna leave the rest of 45 for you. Okay, so your quiz this week will cover these materials. Okay, you should probably expect a quiz either today or tomorrow. But because of the mistake I made last week, I forgot to open the quiz number 18. And I'm going to give you this coming quiz tomorrow. So this allow you time to do quiz number 18. Okay, I apologize. If you need more time, so please give me please just yell at me and just give me a shout. And I will give you a little more time. Okay, I will give you more time. Okay, once again, I apologize, but I will still give you another quiz. And so that's alpha 45. That's alpha 45. And next, I want to get to alpha 46. Alpha 46. Okay. When we look at these questions on alpha 46, you probably would realize factoring is not that straightforward. So alpha 46 is still really the same scenario. It's really the same scenario. Okay, so I set it up like solve for x. Oops, solve for x. That was alpha 45. So you guys, that's your homework. Okay, I trust you can do it. But if you have any questions, please don't hesitate. Solve for x. And here I specifically tell you to use the quadratic formula. Okay, and then we have a question here. Is the polynomial factorable using integers? We love integers, don't we? Right? They're easy, they're simple, right? However, we also need to learn that we don't always get integers. In the real world, we rarely get integers in a lot of cases. In a lot of number related cases, we rarely get integers. Okay, of course you still get, okay, I have 2 flowers, 5 flowers, those are still integers. But in terms of interest rate, when you decide to take an auto loan, a mortgage loan, and those are all fractions. Those important numbers to us, they're all fractions, decimals, right? So mathematics is really a simplified version of all of these. Okay, so we have to be able to know how to do it. We have to be able to know how to do it. So at this point, I think we are going to take a break. Okay, we're going to take a break and we'll come back to work on alpha 46. And we're going to see that why we ask you to use quadratic formula to solve these equations. Okay, why we use a quadratic formula to solve these equations? Because it's very difficult to factor using the technique on factoring with integers. Okay, even though the equation look very simple, but we still have that kind of difficulties. Okay, then we will be talking about this method that works all the time. It works all the time, so we can factor or find the solutions and so on and so forth. Okay, so let's take a break for 10 minutes. Okay, let's take a break for 10 minutes. So break. Okay, so come back at 11:35 a.m. Okay, I'll see you guys in 10 minutes. Resume recording. Okay, 46, alpha 46. As we have seen that factoring with integers, the techniques we learned doesn't always work, right? So what is something that works all the time? Is there something that works all the time? The answer is yes, for quadratic form, for quadratic form. For quadratic form, for the trinomials, we can always find those factors, okay? But it's just sometimes it's not that easy. It's not that easy. Okay, so I want you guys to try to factor. Okay, so please try to factor the first one. Okay. Okay, so I'm going to bring back up this table if you need it. Okay, in case you need it. So could you guys factor this? Say well, we asked you to use a quadratic formula, but before we use a quadratic formula, I want you guys to try to factor this. Okay, I basically want to show you why we use quadratic formula instead. I'm going to give you like 2 minutes, 3 minutes to factor. So factor, please. Using whatever technique, you don't have to use my technique, right? The technique you have learned in your previous experience, your previous teacher taught you. So can you factor x squared plus 3x plus 1? Please. 3 minutes. Did you find something? You know, while you're doing that, I'm trying that too. Okay, so this is 1 times 1. 1 times 1 equals to 1. Okay. And this one is 1 times 1. And then cross multiplication. One times one is one. And one times one is one. One plus one is two. It doesn't match the three. It doesn't work. Okay, so let's try negative one. It still doesn't work. Okay, so this integer method. So can we try anything else? Maybe try negative one over here. When then this become positive one, positive two. It still doesn't match. It seems that no matter what we do, right, it's not going to make that match. Did you guys find the match? I haven't found it. Have you guys found it? Anybody found it? Anybody found the match? Did you find the match? Nothing worked, right? Nothing in that category worked. Even use the method you have learned before, I believe that you're not going to be able to find it. Okay, so you can see that this is the reason why we decided to use a quadratic formula. So these factoring techniques, they're very limiting. They're very limited. They're limited. However, as much as they're limiting, they're useful for academic reasons. They're used for academic reasons. So if you know how to do these techniques, you need these techniques. Okay, you guys, and the student in academic, academic pursuit, right? You're trying to get your degrees and whatever to transfer and so on and so forth. You do need to know these techniques because these, polynomials, trinomial that can be factored. So a lot of them can be factored using the techniques we learned. But we also need to know that if the technique doesn't work, is there a way that works all the time? Yes, there's a way to work all the time. But why don't we use the method that works all the time? That's a question, right? Well, if we can factor using our technique, it's usually simpler. It's usually easier to deal with. If we talk about the method that works all the time, sometimes it can be messy. So when sometimes you have a messier situation, you have a simpler situation, of course, we choose a simpler situation. But these questions in 46 are in the category that, you use these techniques, they're not going to work. But no big deal. If it doesn't factor that easily, we just go ahead and use a quadratic formula. So for none of these in 46, you can factor by the techniques using integers. It just won't work. You can keep trying, but it's not going to work. Okay, we select these questions in such a way that they're not going to work. So what you do with alpha 46, right? You just go straight using quadratic formula. Just go straight using quadratic formula, right? So we try to factor, it didn't work, right? So next, we just solve it. Okay, solve for x. Okay, so we have this if statement equals to 0, right? If the output is 0, and we work with a quadratic formula. Okay, as we're using quadratic formula, I'm going to show you another procedure I prefer to use myself. Okay, so first I will be using b squared minus 4ac. Okay, we know that this is something we use in the quadratic formula. Okay, I prefer this kind of steps. Okay, I will explain to you why in time. Okay, so this is plus minus the square root. So we basically take this piece which is in the square root part, and handle it separately ahead of plugging in the formula. And this b squared minus 4ac give us a lot of information. If you recall what we did in quadratic graphing in that section, you probably have, we covered that part, right? When the quadratic is above, above x-axis, below x-axis, two intersections, one intersection. At that time, we use b squared minus 4ac. In this case, we also have the b squared minus 4ac. Is that a magical number? Will give us a lot of information. For example, if we have b squared minus 4ac here, in this case, a equals to 1, b equals to 3, and c equals to 1. And b squared 4ac here, so we have 3 squared minus 4 times a times c. Right? C is 1. So we end up with 9 minus 4 equals to 5. We have a positive number. A positive number, and this is called a discriminant. Okay, this quantity has a meaning. Discriminant. In a lot of the textbook, they use a special symbol to represent it. Okay, they use a special symbol to represent it. Well, for convenience, you can just use a capital D. You can just use a capital D. D is the first letter of discriminant. Okay, discriminant. So by introducing this intermediate symbol, and we can put this capital D here. We can put this capital D here. Okay, but this discriminant as being positive, it tells us a lot of information. Okay, we expect 2 real number solutions. We expect 2 real number solutions. Okay, that's the beauty about it. Okay, so you know what to expect once you know the discriminant, the value of discriminant. And over here, I'm going to plug in the number. Okay, and b is 3, and d is 5, and a is 1. You see, it's very easy to just put things in place. It looks better organized. It looks better organized. So negative 3 plus minus square root of 5, and the denominator is a 2. Then we're done. We're done. If you like, you can write it into 2 roots. Okay, so these 2 roots are x sub 1, and we will choose the negative sign or positive sign, is really up to you. Okay, so and then you x sub 2 will be the other one. Okay, if you chose minus sign here, you would choose positive sign here. So these are the 2 real number solutions, and you find these 2 real number solutions. Okay, so in terms of how to show work for alpha 46, how to show work, this is all you need to do. This is all you need to do. Okay, and you show work, and you don't really need to write this sentence, even though you know it. You should know it. Okay, we should know it, but you don't have to write it down. But if you want to show off that you know it, certainly you can write it down. Okay, you can write it down. Okay, does that make sense, you guys? Okay, let's try 2 more in this section. Okay, just try to use a quadratic formula and follow this particular procedure that I promote. Okay. So this is number 1, right? So let me choose number 3 and number 6 for you. So number 3 and number 6 for you. Okay, you can try factoring. Okay, I certainly encourage you guys to try the factoring. I wish you guys to experience some frustration. Okay, and some textbook call these cannot be factored by integers prime, but I really don't feel that's a necessary, because they can be factored all the time. They can be factored. They can always be being factored, right? So calling them prime is really, it doesn't have many practical purposes. So just go by b squared minus 4ac. I think it's simpler. Okay. So number 3. Okay, number 3 and number 6. Okay, so you have x squared plus 5x, 7x, sorry, 7x plus 5 equals to 0. Okay, and number 6, you have 3x squared plus 5x plus 1 equals to 0. I'm going to give you guys, let's see, maybe 5 minutes. 5 minutes. Okay, so please try these. Try these. 5 minutes. Okay, 5 minutes. I'm going to turn off my video so you don't feel like I'm staring at you. Okay, so please do these 2 questions. If possible, I would appreciate you guys submit. Okay, I don't mind you submit. All of you submit the same question, submit a different question, or for the same question, there are 2 submissions or 3 submissions, not a problem at all. Okay, so 5 minutes, work on these 2 questions using quadratic formula. Okay, basically we want you to identify the ABCs. Okay, and just use these procedures. Okay, identify ABC, do discriminant. Okay, do discriminant and plug in the formula, identify. Okay, so this is a 2a, negative b, discriminant. Okay, and give these two values if that's clear. Okay, so this is, and how many solutions is expected, that's entirely up to you. Okay, so I just want you to practice using discriminant. Discriminant is a very important piece of information. And the reason is it's called a discriminant because it gives us a lot of information. Okay, so 5 minutes. I'll come back and check on you. I'm going to turn off the video. So I'm not staring at you. So now just work. Okay, take your time. So what have we found? Did you try factoring? You probably didn't try. You probably don't need to try, because oftentimes when you see a couple of numbers, try a couple of numbers, it doesn't work, then you start to know, oh, let's not spend time on there, right? Which is very common, okay? Especially we're talking about this method that works all the time, okay? It works all the time. Even when you can factor with integers, sometimes you still want to use this method to check it, use the quadratic formula. But anyway, without further ado, okay, so let's compare our answers. The discriminant here is 7 squared, 4 times A times C. A is 1, C is 5. So we have 49 subtracting 20 equals to 29. Did you get 29? Okay, so this is -7, and this is 29. And A is 1 there, right? Then the answer would be these two numbers. And you choose one with negative and the other one with positive, or vice versa. Okay, any way you want. The next one, I'm going to also use the same procedure. And B is 5, A is 3, and C is 1. So 25 minus 12. That is 13. So the discriminant is 13, and B is 5. A is 3. Oops, 3. Right? So when we simplify, 2 times 3 is 6. Then we're almost done. We're almost done. There. Now, the next question is that if we cannot get those integer factors, do we have factors? Can we find factors, any factors? Do we have them? The answer is yes, we do. We do have those factors. We do have those factors. They're not going to look very simple. It looks a little messier, but they do exist. They do exist. Okay, so the next question, I'm going to address something, and of course, alpha 47 is similar. Alpha 47 is similar, but I'm going to address the factor issue. Okay, so for 46, number one, which we just did earlier, right? We found the equation, we found the solution to that equation, but we didn't get the factor, right? So in terms of this statement, right, what are the factors? What are the factors? Do we have any? The answer is yes. The factors are composed in the following way. There are two factors. The first factor can be composed as x minus x sub 1. The second factor, it can be composed as x minus x sub x2, or x sub 2. And does this formula work for every quadratic? The answer is yes. The answer is yes. Okay, so what is a general form? What is a general form? Okay, so I'm going to give you the general form. I'm going to give you the general form. Oh, sorry. I'm going to give you the general form, right? Factor any quadratic. Okay, factor any quadratic form. What kind of form is it? Ax squared plus bx plus c. Okay, provided a is not 0. Right? So what are the factors? Here it is. Okay. The factors are going to be a times the same a here, x minus x sub 1 multiply x minus x sub 2. Okay, but what is x1, x2? x1, x sub 1, and x sub 2 are solutions to the if statement equals to 0. That is, okay, x sub 1 would equals to 2a negative b, say minus the square root of b squared minus 4ac. Okay, and x sub 2 is going to be equals to, it's the same formula, we chosen the positive sign. So we can always factor, right? So now let's look at the factors we have for the first one, alpha 46. Alpha 46, right? Factor, that's x squared plus 3x plus 1. Okay, so I'm going to bring back up what we have done. Okay, what we have done is that we solve these equations and we got these numbers. So I'm going to bring this back up here just to show you, because we're going to check the answer, right? We're going to check the answer. So to factor this, and you will first solve the quadratic equation. You make the if statement. And then you solve that quadratic equation. You get these two factors, and then your factor would be like this one. Okay, it will be a times x minus x sub 1, x minus x sub 2. A is 1 here, so you don't have to write it. And what is x1? x1 is this guy. Okay, I want you guys to have your paper pencil with me. Okay, don't just watch, you need to write it down. So those are the factors. But when we were factoring, we always check our work, right? Check. Does it work? Right? Should we simplify this a little bit? Well, maybe we should. Maybe we should. Okay, so we're going to simplify this a little bit. How do we simplify that? Okay, in the first parentheses, we're going to apply the negative sign to the numerator. So as a result, we're going to get a plus 3/2. And then you have a plus √5 over 2. You can see that? Okay, just distribute the negative sign to this fraction. And the second parentheses, we're going to do the same thing. We're going to apply the negative sign to the inside. Wait, Oh, sorry, this should be a positive. I'm sorry, I made a mistake here. Okay, should be a positive. Then when we distribute this negative sign to them, we are going to, once again, we're getting a plus 3/2 minus square root of 5 divided by 2. Okay, so this will be you can stop here. We can stop here. Okay, so we can stop here. But when we check our answer, we want to check if this factored form would indeed equals to the original. Okay, so we'll check if this would indeed, right? This will end up here. So is that true? Right? Is that true? Right? So that's the direction we're going to. So when we check this piece of work, what do we do? Right? So we have x plus 3/2 plus the square root 5 over 2, and we have x plus 3/2 minus square root of 5 over 2. So what we do is that we treat this, okay, we treat this as a plus b multiply a minus b. What is the a? This is the a. Okay, so this is the a. Okay, this is the a. And what is the b? This guy is the b. Okay, that's the b. So a plus b, a minus b. And of course, our a is x plus 3/2. So knowing that form, if we FOIL that, we know that it is equals to a squared plus minus b squared, right? A squared minus b squared. So we're gonna go do that. So we have our a is x plus 3/2 squared minus b squared. So this is our b squared. A squared minus b squared. Okay, this is a plus b, a minus b. So that's equals to a squared minus b squared. On the first parentheses, right, we have a perfect square here. So we're gonna FOIL this. FOIL that, you can FOIL directly, or you can use a special formula. Okay, the special formula I refer to would be a plus b. See, these formulas are very, very frequently showing up in your academic work. Okay, so do get familiar with them. Okay, and practice with them. So you'll have that instinct. You have that instinct. Okay, so use this formula, we get x squared plus 2ab, which is given 3x, and plus 3/2 squared. 3/2 squared, that's 9/4. Subtracting, okay, root 5/2 being squared, that's going to be 5/4, right? All right, so we are almost there. 9/4 minus 5/4, that's a 5/5. That's 5/5. I'm sorry, that's a 4/4. That's a 4/4. Okay, and 4/4 is a 1, which equals to exactly the left-hand side. So they are the factors. Are you convinced? Are you convinced? Yeah, so they're not the pretty factors we used to see, but they're factors. They're factors, right? And then I was just telling you, using quadratic formula this way, you always find your factors. How about those, other techniques that we used before, right? Can we use this technique to replace those other techniques? Of course, of course. Okay, so let me give you another example. Okay, this is an example we have done before. Okay, example done before using the other techniques, right? Using the other technique. Let me take this example. I have x squared minus 7x plus 10. Right? We know the factors. We know what the factors are. Right? So how about I factor using this technique? Right? I'm not going to use this, that a game board, right? So we use this new technique. Okay, which we're going to solve the quadratic equation. Right? So we're going to solve this quadratic equation. Right? So this is the equation. Right? This function, we want the output to be 0. And we're going to plug in the formula. Right? We're going to plug in the formula. And, you can do the discriminant if you wish. The discriminant in these cases. Okay, so over here, you have b squared minus 4ac. That's going to be negative 7 squared minus 4 times a is 1, c is 10. So we have 49 minus 40. And that's equals to 9. It's a perfect square. Okay. And this happens a lot. If it happens to be if you get easy factors, often your square root, under your square root, the discriminant is perfect square. They're going to be perfect square. Okay. And let's compose our x, the solution for x. So x would be equals to, right, 2 times a, 2 times 1. Right? And our b is negative 7, so it's a negative of negative 7, which is a positive 7, plus minus the square root of 9. You see that? Right? And then you're going to simplify this, and we get 2 in the denominator, and the square root of 9 is 3. And negative of negative 7 is a positive 7. Okay, so let's see. What is our x sub 1? Well, you can use 7 minus 3 divided by 2. That's going to give us what? Give us 2. X sub 2 equals to 7 plus 3 divided by 2. You're going to get 5. And we got our factors already. So we got it, right? We're going to compose it the same way as a times x minus x sub 1 multiply x minus x sub 2. So a is 1, x sub 1 is 2, sub 2 is 5. There, we found the factors. So this way of using this method can literally replace the method we have learned earlier, okay, using the integers. Really? Okay. But of course, this sometimes requires a little bit more calculation. Okay, sometimes requires a little more calculation. But anyway, so if you ask for a universal method, a method that works all the time, always give you factors for trinomials, and we got one. Okay, but without further ado, so let's look at 46, 47, and what we've done so far, these are addressing alpha 46, 47, 46, 47. Okay, it applied to all of them. So maybe we should, is this easy for you guys, or do you want some more exercise here? Or you think we can move on? Would you like to try a few more? Yeah. Because sometimes you don't want to have to deal with so many methods, right? And this is one of the situations that, yes, we have a method that works all the time. Okay, works all the time with going the route of quadratic formula. Okay, you guys are not saying anything. Does that are you just telling me these are easy for you? No problem. You get it? Yeah. Okay. So alpha 48 says solve for x using any method. Solve for x using any method, right? So you can use factoring, quadratic formula, completing a square. So I'm going to pass on this section and leave it for you. Alpha 49, however, we're going to stop for a moment. We're going to stop for a moment. Okay, so let's look at alpha 49. Okay, solve for x using any method. Any method we refer to is that, you know, all of these are if statement, right? So using any method, we mean the factoring method, quadratic formula, completing a square. So all these three methods. Okay, so let's take for number 1, for example. X squared plus 3x equals to 10. Okay, before we apply quadratic formula, we have to make sure, okay, we have to make sure that the quadratic formula is for ax squared plus bx plus c equals to 0. So a lot of these equations in 49, there's no 0. So we have to make 0. In all the equations we've done before, they're already made 0. So the output is 0. So therefore, when our output is a 10, right? When the output is 10, we're going to modify the function a little bit. So we're going to make it equal to 0. So we're going to have an additional step, which is called making 0 step. Okay, make 0. How do we make 0? Principle number 3. Okay, subtracting 10 on both sides. And that's going to be 0. Okay, and then you can proceed with any way you want to. And then we can proceed with any way we want to. For example, in this case, I will first think of factor, right? I imagine some of you will be thinking about factoring as well. Because factoring is just, if it works very nicely, right? So I can have x plus 5 and x minus 2 there, right? So you don't need to do discriminant, you don't need to do substitute, you know, those more tedious calculations. So you're gonna have just x plus 5 equals 0. So we still need to use principle number 5, right? But it's much faster, the factoring method. That's why the factoring method is attractive, because it can be, in a lot of academic situations, it can be very straightforward, okay? And the only thing you need to remember is it's important to know, okay, the quadratic formula the quadratic formula is for, okay, the solution, okay, of x equals to, this is plus minus, right, is for, oops, okay, ax squared, so is for this quadratic equation. This is very important to understand. Okay, so a is not 0. This quadratic formula, okay, is for that quadratic equation. That quadratic equation must have a 0 on one side. Okay, it could be on the left, it could be on the left side, it could be on the right side. Okay, but they must be, it must be that way. It must be that way. Okay, so when you have equals to 10, you have to make that 0. That's all. That's all. Okay, so how about we try a couple of questions in 49? Are you ready? Okay, so let's try together. Okay, but I will ask you take the lead. You take the lead. Actually, I'm going to designate some questions for you guys. Okay, so how about Ellen? You are going to do number 6. Okay, Brianna, you are going to do number 7. Francisco, okay, Francisco, you are going to do number 4. Okay, Marcelo, you are going to do number 5. How about that? Yes? And please do submit. Okay, if you don't have a cell phone, you don't have Pronto, submit to, please submit your answer. Your answer to Pronto, or just inbox, or a file upload in chat. How about that? Ready, set, go. I'm going to turn off my video so you don't feel like I'm watching you. Okay, so do you guys have question number 6? Is x times x minus 2 equals to 15? Number 7, is x times x minus 4 equals to 12? Number 4, we have x squared. X squared minus 3x equals to 28. Number 5, we got x times x plus 5 equals to 14. Okay. I'm gonna grab something to drink. I'll be right back. I'll be right back. So please do it. Okay, I do expect your submission. Please All right, guys. Could I see some submission? Just had a spill. Anyway, so let me see. Is there any submission to anywhere? You can control. Not yet. Not yet. Hold on a second. Anybody submitted anything? Let me reload this. I hope it doesn't expire. Where's my pronto button? Did you guys submit? Did any one of you submitted anything? Have you submitted anything? No? Yes? How are we doing? How are we doing? Alan, Brianna, Francisco, Marcelo, have you got a submission? Yes, no, why you guys so quiet? You can say something, can you? Could you please? Just take a picture of your work and submit. Still working on it, okay. So keep on it, okay? Solve it any way you want. Do we submit on Pronto? Sure, you can submit on Pronto. Whichever is the easiest. Okay, you can submit on chat file. You can submit on Pronto. I think Pronto should work. Okay, if it doesn't work, sometimes it's momentarily. But we do have. I am worried a little bit, huh? Maybe you can submit from inbox, because here I don't see the Pronto button. Don't see the Pronto button. I don't know what happened. Hold on. You can submit to the inbox. Still working on your problem. No problem. Once you're done, because I'm gonna go over the questions, the work you've done one by one. And I do want you to take your time to show your best work, right? Let me see what happened to my Pronto. Huh. Come on, Pronto. I'm gonna move this to the other window. Did I see a submission? If you submitted, please let me know so I can look for it. Well, my cell phone should respond to it, right? I have my cell phone right next to me. I got my cell phone. Oh, Brianna submitted. Okay, thank you so much. Okay, I actually cannot show it on the Pronto here. Gee, what's going on with Pronto? My cell phone obviously received it. Okay. Let's see. I got your message, Brianna. I think I did. Right here. Okay. You made a 0 and you factored. You checked. Right. The overall work is good, but there's still some point I like to make clear. Okay. We want to find the final solution. We want to find the, you certainly did, you know, did a good job. You got, you know, you made the 0. So hold on, how can I show this to the class? Can you send it one more time to the inbox? I still cannot show, I don't see the button. I'm gonna re-log in first. Okay, I'm gonna log in Canvas. Okay, keep on working. Okay, keep on working. We will get it. Okay, we have all these different venues of communication. Of course we can make it work. Of course we can make it work. There, Pronto show up when I started over, but it's right now it's authenticating, and I'll be there in no time. Okay, we'll be there in no time. Thank you for sharing your work, Brianna. I got it. I'm not sure how to submit to the email. Don't worry about it. Okay, I already got it. Okay, I already got it. So the Pronto submission. So I'm going to show that to everybody. That's okay, right, Brianna? Okay. So now share. Okay, this is Brianna's work. Thank you so much, Brianna. I really appreciate it. All right, so the work she had is x times x minus 4 equals to 12. And she substituted 12 on both sides. And she got x squared minus 4x minus 12. Okay, so this step, that's correct. Subtracting 12, even though you don't have to show the teacher you're subtracting 12, right? You can go straight here, okay? And then the next step is that I would recommend you remove this equal sign and put that as equals to 0. You know what I mean? This will be more standard writing. But then, of course, you're checking your factors, which is all good, Okay. Okay, you check your factors, but you haven't finished. You haven't finished because we're looking for solutions. We're looking for solutions. Okay, so what you may want to do next, okay, so I'm just going to put on the side. You would just say x minus 6 equals 0 or x plus 2 0. Okay, and then you get x equals to 6 or x equals to negative 2. Then you're done. Then you're done. Okay, so your work is good, but incomplete. Okay, because you didn't give the solution. So I'm going to give you a complete solution to this question. Okay, are you guys ready? And then I'll look at the other submissions. Okay, so let's go back to share screen. Okay, and for number 7. Right, very good job, Brianna. Okay, I think you got it. You just didn't complete the work. Maybe you forgot to take a picture of the. Okay, so what you do is that first you just make 0. X squared minus 4x minus 12 equals to 0. Sorry, minus 12 equals to 0. Okay, factor. That's going to be x minus 6 times x plus 2 equals to 0. okay? Checking your work, okay? I would encourage you guys to check your work on the side. Check your factoring on the side. If you do check, okay? And of course, you should get x squared minus, check your work on the other side. Okay, that's okay. Next, you want to keep the whole body of your work together, right? So you would just get to x minus 6 equals 0, or x plus 2 equals to 0. Okay, and then last but not least, you declare the solution to be x equals to 6 or x equals to -2. And this is viewed as the body of the work. You guys follow me? This is the body of the work. Okay, this is the body of work. Body of work. And we want it to be coherent. Coherent. Is that right spelling? Coherent. Okay, you're checking it on the side. You're checking it on the side. Okay. Let me see. Alan, are you ready to submit? Francisco? Marcelo? Anybody else would like to submit your work? This is the body of the work. Okay, sorry, Alan. So Brianna's done. Okay, so I'm going to reorder this, right? Brianna's done. And we have 3 more to look at. Who else is ready to submit? Good job, Brianna. Let's see the chat message. Where's the chat message? Did I lose it? There. Chat message is right here. Okay. Next person. Next person. We don't have a whole lot of time left. Ellen, are you ready? Obviously, you can see Brianna use the factoring method, right? Factoring method is typically, if you have the factors, typically they're fast. They're fast. You don't have to worry about memorizing any formula. And if you're familiar with the factoring technique, then it comes very quickly. Sent into inbox. Thank you. Okay. Inbox hasn't any responded. All right. Okay. See it. Number 6. Thank you, Alan. So let's look at Alan's submission. Alan's submission. Let's share this work. Got it. And Marcelo submitted. Thank you so much. Okay, so let's look at Alan's. Okay. Right there. Oops. Turn too fast. There. Okay, this is Alan's work. Do you guys see Alan's work? Okay, you should see it. Okay, so now let me check step by step, right? The first step, he copied the question and then he subtract 15 on both sides and all the equal signs in place, and he factored, the factors are correct, and using principle number 5, perfect. Okay, this is perfect. Okay, this is perfect. Wait. Okay, am I too soon? I think the factors may not be right. You guys see it? Because I was thinking, did you check your factors? I was just about to say that, and I realized, wait a minute. You probably were in a rush. You didn't check the factors. Okay. Were you in a rush? You didn't check the factors. I think this should be minus and that should be plus. You follow me? So you may still have a session. I think from your page, I would recommend you check the factors. You check the factors at the bottom. Okay. Had you checked the factors, you probably would discover that your factors are not correct. Okay. All right, Alan. So with that correction, and this will be subtraction, right? So this will be subtraction and this will be adding. So you're gonna get a positive 5, negative 3. Got it? Thank you very much for that contribution. Okay, I almost missed it, but here is a minus 2x, so we need to match that negative 2. Okay, so thank you so much. Did you guys write it down? The corrections? The corrections. Yeah? Okay, so let me look at the next submission. Okay, the next submission, it's Marcelo's submission. Okay. Thank you so much for your submission. Very good job. Okay, so let's check his work. He copied the question properly and he multiplied x squared plus 5x plus 14. I think if you need to subtract 14 on both sides. So here it would be subtracting 14. Okay, and your factors are correct, however, I think. Let me check, right? So let's check together. So you want to check your factors, which is x plus 7 multiply x minus 2. Does that give us x squared plus 5x minus 14? Does it give us that? I think it does, right? So he made a mistake. Marcelo, you should have a minus 14 instead, but you got the factor correct. But here's the dilemma. Here's the dilemma, right? Here's the dilemma. If you have negative 14 here, but in the next step, you could not possibly get the next step. You know what I mean? So at this place, when your teacher grading your work, this doesn't go there because x squared plus 5x plus 14 will never give you these factors. So for that reason, I want you guys to understand, okay? Just because you get the right answer, we also look at the logical connections of your step. Because from this step to the next step, it doesn't go there, you will typically lose point. For example, I would typically, well, no, I'm just overdoing it. I want to get your attention, okay? Between your steps, they have to be logically related. It has to be logically right. So this might cost you points, okay? I would not usually take 5 points off, but I want to get your attention. I would take points off, okay? Now, so continue. That's right. Or the word or, everything else is good. Okay, so your mistake here is not only the mistake here, subtract 14. It will cause another consequential, it will cause another consequence that the logically doesn't go there. Do you understand, Marcelo? Okay, so this is the correction to your work. But overall, I think this is just a minor mistake. This is just a minor mistake. And don't be scared. I won't be taking 5 points off, but I would definitely take some points off. And that's between the two steps. Okay, so thank you so much. Very, very good. Okay, excellent. Okay, so let's go back to, and so we have one more person. One more person. Okay. Francisco, are you ready? I don't want you to feel pressured. If you have it, you have it. If you don't have it, it's no big deal. Okay. So I'm going to do this one for you. Did you submit it? I'm sorry. Did I hear something? Okay. Because if you don't, if you haven't submitted, I'm just going to do it because we have 2 minutes left, right? It's okay if you didn't submit, maybe next time, right? All right. So number 4, we have x squared minus 3x minus 28 equals to 0. And then we factor, right? 4, 7, right? So we're gonna plus 4 x minus 7. I think that will make it, right? However you do it, however you do it. So we end up with x plus 4 equals 0, or x minus 7 equals to 0. So in the end, we get x equals to -4, or x equals to 7. Okay, very good job, very good job. So that's all for today. And do you have any other questions? And thank you for your participation. And I really enjoy to look at your work, okay, and check the steps and give you feedbacks. Okay, I hope that helps everyone. And I will see you guys on Wednesday. And be aware that quiz number 18 is extended. Well, extended was not extended. It was due to my mistake because I assigned the quiz, but I forgot to publish, so you don't get to see it. Okay, I realized that mistake last night, and so I have reset it, so it's available for today and tomorrow. So please get in there to get it done, and you will be probably expecting another quiz. But if you don't have enough time for quiz number 18, so please give me a shout. Okay, or you just give me a yell. Just let me know, so I will set some extension for you. Okay, that's all for today. I will see you guys on Wednesday. a wonderful participation in class, and I wish you to have a wonderful day. Thank you so much.